Hello dear students, today we are going to continue our section 3, chapter 11, properties of waves. As we have studied before the types of waves, but today we are going to calculate the period, the frequency and the wave speed of a wave. So first of all, let's see the frequency and the period and the relation between them. The frequency of a wave describes the number of waves that pass a given point in a unit time. Again, the frequency of the wave describes the number of waves that pass by a given point in a unit time. It's similar to the frequency of the simple harmonic motion. There we said that it's number of cycles or number of rotation in a unit time. Here is also the same, the number of waves in a unit time, so it's similar to it. Again, the period of the wave describes the time required for one complete cycle of vibration of the medium particles. As we have said before, in the simple harmonic motion, the period of the wave means the time needed to make one complete rotation or one complete cycle. Okay, so here is the same. It describes the time required but for one complete cycle of rotation, vibration of the medium particles. The medium particles means that the period of the wave describes the time taken for a complete wavelength to pass a given point. Do you remember the wavelength? As we have said before in our previous session, the wavelength is the distance between two successive crests or two successive troughs. So it is the same. The distance between two successive crests or two successive troughs, it makes a complete cycle. So simply the period of the wave describes the time taken for a complete wavelength to pass in a given point or for making one complete cycle of vibration for the medium particles. So what is the relation between period and frequency? Actually, it is the same relation between frequency and period in the simple harmonic motion. Do you remember the relation between frequency and the period in the simple harmonic motion? Yes, it's the same here. So the relation between the period and the frequency in the simple harmonic motion holds true for waves as well. It's the same, which means the period of the wave is inversely related to the frequency. There is an inverse relationship between the frequency and the period, as we have said before, f equal 1 over t or t equal 1 over f. F is the reciprocal of the period and the period is the reciprocal of the frequency. So the period is inversely related again to the frequency as the same in the simple harmonic motion. So we have studied now the period, the frequency, the relation between them. Now we are gonna study the wave speed. First of all, the speed of the mechanical wave, you have to know that it's constant for any given medium. Any given medium. It's not constant in general. No, it's constant in a given medium. It means in air, for example, it's always constant. The speed of the mechanical wave, like the speed of sound, as we have said before, sound wave is considered a mechanical wave because it needs a medium to travel through. So for example, the speed of the mechanical wave, the speed of sound is constant in air, equals for example 340 meters per second, while in liquids like water equal 1500 meters per second, and in solids about 1850 meters per second. So always the speed of the mechanical wave is constant for a given medium. Okay, how can we calculate it? Now let's see how can we calculate it. You know that in general the v, the speed equal delta x over delta t, the distance or displacement over time. But here the distance here, we are talking about waves, so the distance here is measured in wavelength. It's called wavelength and measured in lambda, symbolized by lambda, while the time here in wave equal the period or the time of one complete cycle or one complete wave. So I just substitute, we are going to substitute delta x by lambda and delta t by t capital for period. So it will be v equal lambda over t. And since you know f equal 1 over t, the frequency equal 1 over period, so we are going to substitute by 1 over t here, 1 over t equal f. So simply v will equals to f multiply lambda. Since lambda divided t, 1 over t equal f, so v simply will be equal to f multiply lambda, means the velocity or the speed of the wave equal the frequency multiply the wavelength. Okay, the wave speed equal frequency multiply the wavelength, f multiply lambda. And by the way, this equation can be applied for all mechanical, both mechanical wave or electromagnetic wave, it doesn't matter. Okay, again, this equation applies for both mechanical and electromagnetic waves. The wave speed equal frequency by wavelength. Let's solve some problems together. Number 1. A piano string tuned to middle C vibrates with a frequency of 262 Hz, assuming that the speed of a sound in air is 343 meters per second. Find the wavelength of the sound wave produced by the string. So now we have the frequency f and we have the speed v. We are going to calculate the wavelength or lambda. So you know that the rule equal, or the equation says that v equal f multiply lambda. So lambda equal v divided f. Okay, so v equals 343 divided 262, which refers to the frequency, equals 1.31 meter. Here is the wavelength measured in meter. Another example. The red light emitted by a Heine laser has a wavelength of 633 nanometer in air. By the way, nanometer equals 1 multiplied 10 to the power negative 9 meter. So we are going to convert this number 633 from nanometer into meter to solve the problem. Okay, don't forget. So let's continue. In air and travels at 3 multiplied 10 to the power 8 meter per second. So here is the speed. Find the frequency of laser light. So here is a wavelength and here is the speed. We are gonna find the frequency. So simply v equal f multiply lambda. Again the same equation. So f equal v divided lambda. v 3 multiplied 10 to the power 8. Lambda after conversion it will be 633 multiplied 10 to the power negative 9. So by calculation it equals to 4.73 multiplied 10 to the power 14 Hertz. And by the way, you can leave it as 10 to the power 13 Hertz, or you can convert it in other unit of frequency. So kilohertz, for example, equal 10 to the power 3 Hertz. Megahertz equal 10 to the power 6 Hertz. Gigahertz equal 10 to the power 9 Hertz, while terahertz equal 10 to the power 12 Hertz. So we can simply make this number or this value divided any one of those ones to convert it into other unit. Number 3. A tuning fork produces a sound with a frequency of 256 Hz and a wavelength in air of 1.35 meter. So here is the wavelength and here is the frequency. So what value does this give for the speed of a sound in air? So now we are going to calculate the speed of sound. The speed simply equal v equal f multiply lambda. So by direct substitution it equals to 256 refers to the frequency multiply 1.35 refers to the wavelength equals by calculation 189.6 meter per second. And what would be the wavelength of this same sound in water, in which sound travels at 1500 meters per second? So here is a new speed and you are going to calculate the wavelength again, but the wavelength instead of this one by using the same frequency, and the new speed we are going to calculate a new wavelength. So the wavelength equals, since v equal f multiply lambda, so lambda equals simply v divided f, as we have said before here. So 1500 the new speed divided to 156 the frequency equal 5.86 meters. So study well these examples, these problems, and you can solve these ones as homework, okay, as practice. Until our next meeting, see you, bye bye.